Greetings everyone. Today I will present two different computer programs, each dedicated to solving mathematical problems using two different numerical methods. These are the secant method and the Simpson's 3-8 rule for numerical integration. Second method is also known as the method for false position. Is a numerical technique which is an open method for finding the roots of the real valued function. It is an iterative method and it is common used when other root finding methods such as bisection method or Newton-Raphson's method may be not as efficient and suitable. Let us recall our Newton-Raphson. So in Newton-Raphson, in this method, it uses the tangent line of the function, which specifically the slope, which is basically the derivative of the function. One of the problems that you might encounter in using the Newton-Raphson is the difficulty on solving the slope. To solve this problem, the mathematician made a solution by formulating a secant method. So in secant method, instead of doing the derivative on a single point, you will pick 2 points to become a basis of your slope. Aside from this example, we have the function of y is equal to fx, and then we need to get 2 points to solve the values of the x. So on the first one is x sub 0 and x sub 1. Now in second method, we have two initial guess. Let us label it as x sub 0 and x sub 1. Unlike the bracketing method, you have two initial guesses. The x sub new or this x sub 2 must be inside of those two initial guesses. But in second method, since we also tell this as open system of the numerical methods to solve the roots, the x or the roots can be outside from the initial guesses. Now to derive the equation to solve the x new, by formula, diba, we know that slope is rise all over run. So in this case, we need to form a triangle to see and to solve our slope. So in here, we have our 2 points. We have our x sub 0 and x sub 1. Therefore, our slope will be from the rise. We have the function of f of x, function of f of x 0 minus the function of f of x1. All over the run, it's from of the Newton-Raphson. We have x new is equals to x minus f of f prime of x, where we separate the f prime of x as we know that f prime of x is equal to the slope. So the final formula for this second method is x new is equal to x sub 0 minus the function of f of x0 times x sub 0 minus x sub 1 all over f of x sub 0 minus f of x sub 1. For the scope and delimitation, this software is designed exclusively for solving polynomials using secant method. It can be determined the root of polynomials ranging from 3rd to the 10th degree, as quadratic equations can be addressed separately through the quadratic formula. This program features the presentation of tabulated data, allowing the users to specify the desired number of decimal places. Additionally, it incorporates calculation of computer error to attain precision in solving the roots. This program imposes certain conditions, and if they are not met, users must restart the process from the beginning. The program will conclude its execution when the computed approximated percent relative error falls beyond or falls below the user's relative criterion. For the programming language, this program uses C++. For the algorithm of the program, first, the user must enter the degree of the function, which is the third or to 10th degree of the polynomial only. Second, it is enter its corresponding coefficients of the polynomial. Third is to enter the number of decimal places that a user wants to display on the screen. Fourth, enter the pre-specified criterion, such as what will be the percentage error, or the user want what percent error that the user want to achieve on the program. Fifth, enter the initial values for the x sub 1 and x sub 0. Note, it must be a different values. If you will put a same value for x sub 1, x sub 0, then you will be restarted the program from the beginning. After you enter the x sub 1, x sub 0, the program will solve for the x new, which is given the formula, the x new is equals to x sub 1 minus the function of x sub 1 times the difference between f sub 1 of x sub 0 all over the function of x sub 1 minus the function of x sub 0. Then we set the value for the x sub 0 into x sub I in the program, and the x sub 1 is x sub I plus 1. After the initial values or until then they will just solving the iterations up to this percentage error, with x new of the present minus the x new of the previous all over the x new of the present times 100 is less the pre-specified criterion set by the user. Then after, if the sequence is satisfied, the program will print the new root, which is the x new, and the program will ends.
For our program, we will now discussing this second method. So we are using here is the Visual Studio, a VS Code, to put the C++ program. Then we have to declare the header file first for the C++. First, as we have the first include IOStream. This is the header file that contains the function of the program. Next is the hashtag include IO main IP, which is the header file that used for manipulating the output of the C++, which includes the set width and position. Next, this is hashtag include the CMAT, which is the header file that declares the set functions to compute common mathematical operations. And hashtag include conio.h, the header file that contains the function of the console input output, which includes the clear screen, get, and the return. So using namespace std makes all things under the standard namespace std. For double, we have declared the variables of the number of the decimal places. We have the x sub 0, x sub 1, x sub 2, x sub 0 n, x sub 1 n, f of 0, fx of 1, f1, n, and es. Integer or int degree 1 and ir is the for the whole numbers. This one is the where the program start when we int main. For cout, this is the where you will see first on the second the screen when you run the program. Well, this program root count then the first one that we will be inputting is the degree of the function. So please enter the degree of the function between 3 and 10. If the degree of the function is greater than 10, then it must be produced na magkakaroon ng ganitong error. Pero kung wala, if the degree is less than 10, plus also magkakaroon ng ganitong error. For our degree, less than or equal to 10, magkakaroon siya ng degree of coefficients. So, maproduce na siya ng degree of coefficients which is from what degree na sinimulan. For example, if we will put the degree of 3, so we will see on the screen that input of A x sub 3 or A3, A2, A1. Yan. And for C out, we will enter the decimal places to be displayed. So what will be the decimal place number where the user wanted to put? Then this part will declare or the initial value for x sub 0 and x sub 1. So after putting, if the initial value of x sub 0 are equal, x sub 0 and x sub 1 are equal, this message will be presented on the screen, and you will be restart the program again. So it will not run through, but it will restart the program again. So if tama, or if you were right to, if the initial values of x sub 0 x sub 1 are correctly inputted, which means they're not equal, so we can now proceed the second calculation. So it will present to you the number of iterations. It depends again on the process. If the specified number of values or the specified ES is greater than the percentage error is greater than the specified what the user wanted to be, then the iteration will still continue. If it's less than the specified criterion, then the program will start, and we will produce the x new, the answer of the equation, the root of the equation. So this is the second method program.
For the sample problem of the second method, we are going to solve the roots of this function x cubed plus 11x squared plus 2784x minus 13,657. We are going to approximate initial value of 14 and 41. For the x sub 0 is 14 and x sub 1 is 41, and set up the answers up to 10 decimal places.
For the execution of this second method, again, this program obtains the roots of the polynomial with the third and 10th degree. So in this direction, input the polynomial with degrees ranging from 3 to 10, which is 3. The function is 3. Then we will need to enter the coefficients of the function. We have, for the x cubed is 1. For the second degree, we have 113, positive 113. For first degree is positive 2784. And for the 0th degree, we have negative 13,657. So the number of decimal places to be displayed, as the problem said, it would be 10. Pre-specified criterion, let's say we want 0.0001 of error. The initial value, the problem mentioned 14, and the x sub 1 or the x sub 1 is 41. So This produces the iterations. Program says, therefore, at the 8 iterations, the x new or the x root of the function is 4.172715740006. So this is the second calculator. For us to check if our answer is correct using the second method, we incorporate the function to solve in this template. So with x sub 0 is equal to 14 at x sub 1, x sub 1 is equal to 41. Our new x sub 2 is stopped on the 7th iteration, but it is also the same in the 8th iteration. So this is the answer, and it seems equal with the output of the calculator.
For our last topic, we have the Simpson's 3-8 rule. The Simpson's 3-8 rule is a numerical integration technique used for approximation the definite integral of a function over a given interval. It is an extension of the simpler Simpson's one-third rule, but instead of using quadratic approximations, it uses cubic approximations to provide a more accurate estimate. The 3-8 rule is particularly useful when the number of intervals is multiple of 3. While it may not be as commonly used as the standard Simpson's rule, which is employed when the number of interval is even, the 3-8 rule provides more accurate approximation in certain cases. Here is the general formula of the Simpson's 3-8 rule. So we have the integral of the function dx from a to b, the limits from a to b. So it can be solved using this general formula. We have 3h all over 8 multiplied to the functions of y sub 0 plus y sub n plus 3 times the sum of the y sub 1, y sub 2 plus up to y sub n minus 1 plus 2 times or multiplication 2 multiplied to y sub 3 plus y sub 6 to y sub n minus 3, where the h is equal to a plus b all over n, where n is the number of intervals that we'll be using. The scope and the limitation of this program for Simpson's 3-8 rule. First, the subinterval n must be multiples of 3. So the formula to be functional and be precise. Second, the higher the value of n in multiples of 3, the more accurate the value of the output will be on the true value of the definite integral. Simpson's 3-8 rule, as discussed earlier, it is based on the cubic interpolation to estimate the definite integrals of nonlinear functions. Our next scope and delimitation for number 3, the program cannot be used accurately for trigonometric functions due to the differences in the upper and lower limit input modes, such as degrees and radians form. Last, the input of the function to be solved is not included when the program runs. Therefore, it should be encoded within the source code before running the program. It's the same program language that we will be using for Simpson's 3-8 rule, which is C++. The algorithm is this. First, you need to modify the program by changing the given function or the given function to solve. What will be next is to enter the limits of the integration, which is the from A to B. Third is enter the subintervals, which it should be multiples of 3. Fourth, enter the number of decimal places to be displayed, whatever the user wanted to be. And fifth is to solve for h. Next is to evaluate the integration and store it on these arrays. Seventh, solve for the integral using the general formula we have been discussed earlier. And eight is to print or to produce the integral. Then that's the end of the program.
For Simpson's rule, we have the two header files only. The first one is the IOStream and the CMAT that's being discussed on the second method. And with the start program here is from first one I declare we will declare what the function we are be using. In this kind of program for Simpson's 3.8 rule, it cannot be placed inside of the you cannot you cannot input the equation during the execution of the program. So it is for um, for the convenience also of the user. Depends on how or what kind of type of iterations or how many um, intervals that he or she needed, or also the versatility of the limits that you can put inside of the equation. So since we need to fix a certain function, so we need to include it here inside of the program. So in this case, the sample problem for um, second method is being incorporated here as been tackled before. Then this starts the program. So with n is the declaring the values for n and I. For n is for the subintervals and n is for the loop. So first input will be the limits of the integration. So which is the initial limit is the lower limit, which is the a, and the final limit or the upper limit is the b, and then the number of the intervals should be multiples of 3. So it should be the next one, and then the last part to be entered is the decimal places that the user wants to uh, present the answer, or how it will be presented the answer. So yeah, and then next the program will start to compute it for getting the number of intervals using this equation is double x is equals to double n plus 1, which after the h can be get into this formula for it's common for trapezoid, Simpson's 1/3 and Simpson's 3/8 rule. So in here we get with the width of the intervals of h is equals to b minus a all over n, and then for the loop, let's evaluate this is to evaluate them the x sub 0 to x sub n, y sub 0 to y sub n, and store it on the arrays. So after evaluating all the uh items, or I mean the points of the integrations for the Simpsons 3/8 rule, the program now will serve the integral as it expressed in this kind of the program. So 3h, do we know that the general formula is 3h or 3h over 8 times the y sub 0, y plus n, plus 3 times the sum of y sub 1, 2, 4, or n minus 1. And this one is 2 plus 2 times y sub 3, y sub 6, y sub 9, n minus 3. So, yan. This is the summary of this equation, and then after the computer would solve the problem, the program solve the all of the equations needed, it will produce an output, which is here the definite integral is, and then that the program will pause.
Here is the function that we're going to solve for the Simpson's tree rule. We need to find the integral, the function e sine raised to sine x all over x cubed minus 10x squared plus 4 to the limits of from 0.15 to 0.45. We will solve using the 14 segments to implement the Simpson's 3/8 rule.
For the Simpson's 3/8 rule calculator, okay, the program specifies that the solution for the function of e raised to sine x slash x cubed minus 10x squared plus 4, then you first enter the limits of the integration. So the limits of this integration is from 0.15 to 0.45. So the initial limit is 0.15 and the final limit is 0.45. You can show that the answer is, okay, sorry, the interval pala. Enter the number of intervals, it should be multiples of 3, where you say the problem states that we need to 12. And the number of decimal to be displayed is 15. So the definite integral from this final problem is 0.137955599564665. Okay, in order for us to check if the answer is correct, we incorporate to solve this problem using the Excel file or using the program of Excel. As we showed here, this is the Simpson's 3/8 rule for that specific function. And the answer of 0.13799 9555995646665 is also in this set of template.